Hello, everyone. Welcome to Aptera Owners Club. So, John Stossel put out his second part of the Inconvenient Facts about electric cars, so I thought I would finish the series and respond to that. Now, this is a video for people who like seeing facts and learning about things that are contrary to their preconceived notions. If most people have a bias, and if you want confirmation bias and you want information to confirm your biases, this video is not for you. If you're the kind of person that likes to see and learn about facts that maybe challenge their preconceived notions, then this video might have information that you may not have heard of before and maybe will make you think a little differently about things. So if you're the kind of person who just has decided that electric vehicles are bad and want information to confirm that, don't watch this video. Click off of it. You're not going to like the video. If you're also the kind of person that thinks petroleum is bad and we need to get rid of it completely right now, you're probably also not going to like this video because I think petroleum, unfortunately, is going to be with us for the foreseeable future because there's some things that are going to be very difficult to replace with petroleum. Not forever, but I just don't think the technology is there right now. So anyways, there's certain people that I think enjoy learning things that they weren't aware of and things that challenge their notions. And if you're that kind of person, stay tuned. This may be interesting for you. If you like to stay in your bubble and get confirmation bias all the time, please click off. You're not going to like this video. Okay, well, let's respond and get started.
You probably don't know. This is part 2 of our series on electric cars. We keep hearing
the future of the auto industry is electric, and battery technology.
Battery technology. That's key because we need to store the electric power. But storing large amounts of energy in batteries has a problem.
Batteries are really lousy at storing energy.
They leak energy constantly.
They leak, they don't hold a lot.
Physicist Mark Mills says electric cars are great, but
oil begins with a huge advantage over the chemicals that are in a battery. Oil has about 5,000% more energy in it per pound. And we see this in electric cars. Electric cars' battery weighs 1,000 pounds. That's what the battery weighs. It's replacing about 80 pounds of gasoline.
All right, you're talking today, but the batteries are going to get smaller and better.
They've gotten way more powerful, long-lasting, and affordable. All of this is just a prologue to what the next batteries are going to do.
I can't wait. Will they be something like the one Iron Man has?
Yeah, I can fly.
Iron Man with the power pack that he puts in his chest, or the Terminator.
Could happen. Things improve.
Engineers are really good at making things better, but they can't make them better than the laws of physics permit. That will never happen in any place except comic books.
That's Inconvenient Fact 4. Miracle batteries, powerful enough to replace fossil fuels, are a fantasy.
Okay, so let's stop there. What they're saying is absolutely true. Gasoline and fossil fuels have incredible energy density, and they are way more energy dense than any battery. And they're going to be way more dense than any battery that we can even conceive of at this point. That's an absolute fact. But you don't need batteries to be as dense as gasoline. You just need them to be dense enough to do the thing that you want. Like, we could probably make a gasoline-powered flashlight that lasted like 100 years on one fill-up. But no one needs that. So everyone uses battery-powered flashlights. And we already have the technology to have a car that goes 500 miles. And it is a little bit heavier than, about 800 pounds heavier than the other car. Like a Tesla Model 3 is about 3,600 pounds. A Honda Accord's about 3,200 pounds. So it's not a huge difference. So making the car a little bit heavier, it will have enough range to do what most people want to do. Like, 300-400 miles, that's the range of a gas car. Now, gas cars do fill up much faster. You can fill up a gas car in like 2-3 minutes, and you can fill up a electric car. It still takes like 30-40 minutes. Those kinds of things are going to get better. Like, battery technology is definitely going to get better. It's going to get more dense. It's not going to get a lot more dense. I mean, I think it would be pretty impressive if batteries got twice as much density as they have now. and improved 100%. But yeah, they're not going to get 5,000% better. That's just not happening. Um, but batteries that charge faster, that's definitely happening. They're working on that. Solid state batteries, sodium ion batteries. These batteries are going to charge faster. Um, and someone's going to come up with technology probably that we haven't thought of before, but fast charging batteries are definitely a possibility. Batteries that are dense enough to replace fossil fuels in terms of density, that's not happening. That's absolutely true. But again, you just need the amount of energy density that will fulfill the work that you want it to do. Now a lot of lawn mowers and things like that are going to battery. Leaf blowers are going to battery because they just have enough density to do the work. And like, for example, nuclear fuel is way more dense than fossil fuel, but that doesn't mean nuclear fuel is better than fossil fuels for everything. It's just not. So density is not the end all and be all of energy. So fossil fuels are very dense, and there are probably applications that electricity will never replace fossil fuels for. Like, I don't conceive of a way of making like long haul flights be electric. That just there's not the batteries would weigh too much to fly. So for long haul flights, you're probably going to have to use jet fuel at least for the foreseeable future, unless some new technology that we can't conceive of comes about. Um, but like for short haul flights, battery technology is going to be fine. But for long haul flights, it's too heavy. It's not going to work. But this miracle batteries powerful enough to replace fossil fuels for many applications are definitely happening. And miracle, batteries powerful enough to replace fossil fuels in cars, that's basically already happened. We just need to get batteries that charge faster, and then it'll be essentially like a regular car. Right now, the big drawback is there's not enough charging stations, and charging electric car takes like 30 minutes versus 3 minutes, which is somewhat of a hassle. I think people can get around that. Most people that drive Teslas and electric cars now have gotten used to just like charging at places where they stop for lunch, and they're going to stay there for 30 minutes anyway, and they're kind of okay with it. So there's workarounds, but I mean, ideally, it would be better if you could get it to charge the same as a gas car. But then people they get used to new ways of doing things. I think people are more adaptable than we give them credit for.
Because nature is not nice to humans, we store energy for when it's going to be really cold or really hot. The people who imagine an energy transition would want to build windmills and solar panels and store all that energy in batteries. But you do the arithmetic and you find out you need to build about $100 trillion worth of batteries to store the same amount of energy that Europe has in storage now for this winter. And it would
Okay, so again, that's a ridiculous thing that they're saying is like, so Europe stores natural gas and fossil fuels to heat. They store heating oil to heat for the winter, and he's saying that they're going to need a ridiculous amount of batteries to replace that. Of course, but no one's thinking about replacing heating oils with electricity. Electricity is a very inefficient way of heating things. The reason that gas cars are so inefficient at transportation is that they generate so much heat. The gas engines lose like 70 to 80% of their energy in heat instead of turning it into mechanical energy to go. But fossil fuels are great at generating heat. I mean, that's what they do. They just generate a ton of heat. And so if you want to generate heat, why would you replace something of fossil fuels? It's really good at that with something that's less good at that, which is electricity. Electricity is not very good at generating heat. It just takes a lot of electricity to generate heat, which is why if you turn on the heater in an electric car, you're going to lose a bit of range because it's not very good at that. But electricity is very good at converting energy to mechanical energy, turning motors, making cars go. I mean, it's really good at that. It's terrible at generating heat. And so Europe uses heating oil and natural gas to heat their buildings. And why in the world would they make battery storage to try to replace that? It makes zero sense.
take the world's battery factories about.
And no one is saying that they're going to do that. No one's suggesting let's replace heating oil with electricity. It's a straw man argument. No one is saying that.
400 years to manufacture that many batteries.
400 years.
Yeah, no one is going to do that. It's ridiculous.
Politicians don't mention that.
They don't mention it because no one's suggesting to do it.
Leads to another problem the politicians don't mention. They say every car will be electric.
California will require all new cars sold to be zero-emission vehicles.
If that were somehow to happen.
That means a lot more electric vehicles drawing power from the grid.
But the grid is already limited. So limited that last summer, California's governor told people, don't use your electric car.
Okay, again, that's not what they said. They said, don't charge your car from a certain time period. Okay, so here's a report from Fox Business. So California urges residents, again, not to charge EVs on busy travel weekend. This was Labor Day weekend. So what they said is, avoid using large appliances or charging their electric vehicles between 4 and 9 p.m. So they're asking people for 5 hours of the day not to charge their electric vehicle. You can use your electric vehicle, you can drive it whenever you want. They just would like you not to charge it for those 5 hours. It's completely fine to charge it the other 19 hours of the day. And here's the reason for that. This is the reason. If you look at California's electric generation, what happens is you have this generation, and then this is the net load. The load goes down because during the day, around after 6 or 7 p.m., the solar in California's grid goes up. And then just as the sun is setting, that's when everyone gets home and the electricity use goes up. This is called the duck curve because it looks sort of like the duck curve. So in this time period, there's way too much electricity being made. And in this time period, there's too much electricity being made and it's very hard to keep up with the demand. So they're asking you from 4 to 9 p.m., this area of the ramp, not to add extra load on the electric grid. They're completely fine with you charging it at this time. And here's why it is. Here's explanations of it. There, in this middle part, California has invested so much into solar energy that they over-generate solar electricity during the middle of the day. They have way more capacity they're generating way more than they can use. And it's so much that they were having to pay other states to take their electricity. And many times California is shutting down its solar because the grid can't handle the amount of solar power that's being generated. No one's using it, so they're just backing up on the grid. So this is back in 2017, but this is continuing. On 14 days in March, Arizona Utilities got a gift from California, free solar power. Well, actually better than free. California produced so much solar power on those days that it paid Arizona to take its excess energy. And if you look at this, this is the kind of, I'm actually surprised John Stossel didn't use this as as one of the gotcha facts. If you look at the amount of electricity that our grid takes on, so let's do the calculation for the U.S. In 2020, there were about 290 million cars registered in the U.S. In 2020, the U.S. grid had about 1,117 terawatts of utility electricity capacity. If all the cars were EVs and charging at 7 kilowatts, they would need 2,000 kilowatts. That's double the grid capacity. If they charge at 50 kilowatts, they would need 12 times the capacity, which if you look at it, sounds ridiculous. Like there's no way that you're going to double the electric grid capacity of the US or increase it by 13 times. But what they don't mention is that there's no way that you're going to have all 300 million cars charging simultaneously at the same time. And they're not going to charge for 24 hours a day. They're going to just charge for the time that they need. And so if you do the actual calculation, the US grid generated 4,000 terawatt hours of electricity in a year. If you look at the average American drive, which is about 13,500 miles, and if you were an EV, it would require about 4,000 kilowatt hours per year to drive that much. every single car in the US were turned into EVs now, you would need 27.6% more electric production in the US. So that's reasonable. You're going to need 30% more power if everything else stays the same. And I'll show you why everything else doesn't necessarily have to stay the same. So this is a kind of an overestimation. But California, which is probably the most aggressive in changing to EVs, has said no new cars will be sold after 2035 that are not EVs. So that means that until 2035, people are still selling gas-powered vehicles. And then they're going to start switching over in 2035. It's not like in 2035, instantly every car in California has to be an EV. If you have a gas car and you buy it in 2034, you can use it for the life of that car. And most cars last about 20 years now. Cars are very reliable, and I think the average lifespan of a car now is about 20 years. So that means that probably there's going to be gas cars in California until easily 2055. And if you buy a car from out of state, you can probably bring it over to California still. They're just like the dealerships in California can't do it. And I imagine the other states will be slower to adopt these. So complete transition to EVs in America is probably not happening until like 2060 at the earliest. And by 2060, to say that we're not going to build 30% more power in the US, I think that's a very doable thing.
Asking residents to avoid charging their EVs in order to conserve energy.
Yeah, and what they don't mention, it's for 5 hours a day.
Roughly speaking, you have to double your electric grid to move the energy out of gasoline into the electric.
So they are kind of saying that. They're going by this thing and saying that you would need to double your electric grid, which is false. That just it's based on the presumption that all electric cars in the entire United States will charge simultaneously. And have we ever coordinated 300 million people to do everything at once at the same time? I don't think so. And it's just not going to happen.
Electric sector. No one is planning to double the electric grid in California, so there'll be rationing.
Rationing. When there isn't enough electricity, cities will simply turn some of the power off.
So actually, many people say that electric cars are going to be the answer to electric grid problems, because the electric grid problem, at least in California and probably in many other places as renewables come online, the problem with renewables like wind and solar is that you can't control when they give you power. Like the wind blows when it wants to, and the sun comes out only during the day. You can't make the sun come out at night. So you're making too much solar during the day, and you have excess capacity and you're over generating. And then at night, when people come home and they need it, you have to depend on other sources of fuel: wind, hydroelectric, fossil fuels, nuclear energy. And solar is just off the picture at night. And that's when people come back from home so at the time the sun is setting, that's when the electric use goes up. If you had a ton of electric cars in California and you got them to charge during this overproduction, then you wouldn't have to pay Arizona to take your power. You could put your power into your cars, and then when you got home, you could plug in your cars and use the car's battery pack to level out this power. So it's basically a load leveling problem. And electric cars, if you got vehicle to home or vehicle to grid happening, they would actually help the grid instead of hurting the grid. And in fact, there are companies that are using old EV batteries. There's a company in California, they have a large battery farm in Lancaster, north of LA, and they use old EV batteries that are degraded, so they're not very useful as EV batteries anymore, but they still hold the charge. They just are not, they've lost about 70, they've lost like down to like half or 70% of their power. so they're not very good as EV batteries anymore. But they are using them for grid storage, and what they're doing is that company is buying the power here when it's cheap, and they're selling it here when it's expensive. And with that, they're making money by reusing old EV batteries to do that. And that's probably where EV batteries are going to go. I'm surprised that they did not talk about the problem of all these EV batteries. If we go to full EVs in America, it's going to generate a ton of batteries that at the end of life we're going to need to do something about them. And it's a big problem. It's a big issue. And probably the thing that's going to happen is they're going to be used for grid storage, and then afterward they can be recycled. There's a company called Redwood Industries that's recycling lithium-ion batteries. So that's something they didn't mention. That is a problem, but it is a problem that we need to deal with. Is what are we going to do with these used batteries? Another thing they didn't mention, which I'm surprised, is that they didn't mention the cost of replacing these batteries. Batteries are very expensive, and there is a cost to replacing them. But what we know is that these EV batteries last a long time. Tesla, there was a company called Tesloop that used to run a shuttle service between LA and Las Vegas using Tesla cars, and they would fast charge them, which was really hard on batteries and made them degrade faster. But they put like 400, 500,000 miles on these cars, and the batteries were still pretty good. They still had about 80% of their capacity, even after like 500,000 miles. So these EV batteries are likely, if you treat them well, I mean, they were abusing these batteries and they lasted that long. If you treat them well, they will probably outlive the rest of the car. They'll probably outlive the chassis of the car.
That's inconvenient fact 5. We just don't have enough electricity for all electric cars.
Okay, I'm going to see if...
And we'll have even less of it if we try to get all our electricity from renewable energy like wind and solar. Our president says
we're going to achieve a carbon pollution-free electric sector by the year 2035.
And gullible media believe it. It's amazing that all these smart people and supposed leaders say these things. It's upsetting.
It really has been an extraordinary accomplishment of propaganda, and there's no other word for it.
Oil and gas is going to take everything we know and love.
Wind and solar, renewable versus oil and gas. It's almost infantile. It's really, it's distressing because it's so silly.
Because even if engineers invent much better wind turbines and solar panels and power lines and batteries,
you're still drilling things, you're still digging up stuff, you're still building machines that wear out, we're still driving big trucks, whether you drill a gas well or build a wind turbine. It's all the same, really. It's just big machines to make lots of energy for humanity. It's not magical transformation. In many respects, the parts that aren't different are worse, unfortunately.
the politicians are making us pay more to do things that hurt the environment. Europe going back to coal.
Burning coal in homes and open stoves because they're so afraid they're going to freeze this winter.
People fearful of winter shortages wait for days and nights to stock up on heating fuel.
Lines going for miles in Poland. These are people picking up coal to take home to be sure they won't freeze this winter. This is crazy. So what we've done now...
Okay, so let's unpack that a little bit. First of all, the most recent thing, the Poland thing. That has nothing to do with policy. That has to do with the Ukraine war. Because of the Ukrainian war, Europe has decided they're not going to buy natural gas from Russia, and natural gas from Russia was the main source of heating for much of Europe. And so, because of the sanctions on Russia, because of the Ukrainian war, Russia is not buying that, and so they don't really have a great alternative source for heat. And so people are kind of scared and desperate for that. That is a major problem. That has nothing to do with policy of them forcing people to burn coal in their houses. People are just scared that there's not going to be enough natural gas because of the Ukrainian war and because the supply lines from Russia have been cut off. And then they're talking about renewable energies, and in a way, I agree with them. We can't get away from fossil fuels completely. There's things that we are always going to need fossil fuel for. Long haul flights, probably long haul trucking is not going to is not going to be viable with batteries. And so we're going to need to use that. And of course, we're going to need these fossil fuels for plastics, for petrochemicals that we use, and we're going to need them for heating because fossil fuels are really good at heating. And it's very unlikely we're going to replace fossil fuels for those uses for the foreseeable future. But in terms of electric cars, which is what they're talking about, electric cars are pretty good. Like electric cars are very, very good. And the battery technology is there and it's much more efficient. And even if you are getting the electricity from a fossil fuel plant, it's still more efficient. You will still burn less fossil fuels per mile driven than if you were to put the fossil fuel directly in a gas car. So if you take the same amount of gasoline and put it through a power plant and then turn it into electricity and then put it in your EV will go farther than putting it in a car, like other things being equal. I mean, as long as you're not using a Hummer EV as the example of an EV and a Prius hybrid as the example of a gas-powered car. All things being equal, the EV is going to be more efficient, even if you are burning fossil fuels to generate the electricity. Now, that's not true. 100% of our electricity does not come from fossil fuels. Some of it comes from solar, some of it comes from wind, and it's going to convert to more renewables. There's tidal power coming online. And I know that nuclear power has been demonized by environmentalists, but it's very unlikely we're going to reach our goals without nuclear power. So nuclear power is going to have to be built, in my opinion.
Is had our energy systems designed by bureaucrats instead of by engineers. And what we're getting is worse energy, more expensive energy, higher environmental impacts. That's what we're doing.
As for electric cars?
Okay, so I wanted to talk about some other things. So remember in this thing, they said that we would need about 27.6% more electricity if we converted our entire gasoline cars to EVs. And that, again, that's not likely to happen until at least, 2060, if you run the numbers. What people are not told, so it's a very common meme to say, oh, you basically, electric cars run on fossil fuels because you burn fossil fuels to get the electricity. The corollary is also true. It takes a lot of electricity to make gasoline. So you can say gasoline cars run on electricity in a way. So this is a very old video, but still valid. This is about 8 years ago, Fully Charged did this.
When I visited an oil refinery to make an episode of Channel 5's How Do They Do It series, I noticed this huge substation next to the car park when I arrived. Here's an illustration of the thickness of my brain. I said to the camera crew, "I didn't know refining oil generated electricity." Uh-huh. I was later disabused of this notion when the head of engineering at the refinery explained proudly that we use more electricity in a year than Coventry and Leicester combined. Yes, that's quite a lot of electricity. But how much, I hear you ask? Well, hang on a minute. Very importantly, these big UK refineries use so much electricity that they have their own dedicated feed from the nearest power station. In all three cases, the nearest power stations are coal-powered, so they are using the dirtiest form of electricity to refine the dirtiest form of fuel. No critic of electric cars ever mentions this rather glaring fact. In 2005, the most recent year that figures are available, the three big refineries in the UK used 5,600 gigawatt-hours of electricity to refine oil. That's 5.5 billion kilowatt-hours. The best guess of the amount of electricity needed to refine 1 gallon of petrol is somewhere around 4.5 kilowatt-hours. That electricity...
All right, so I think that's where Elon Musk got this. So it takes a ridiculous amount of energy just to refine gasoline. And these gasoline refineries are some of the largest users of electricity in the areas that they're located in. So if you look at like whatever city that they're located in, they're probably like the largest user of electricity in that city. And so this was an interview with Elon Musk back from 2011, and he said You have enough electricity to power all the cars in the country if you just stop refining gasoline. You take an average of 5 kilowatt hours to refine 1 gallon of gasoline. Something like the Model S can go 20 miles on 5 kilowatt hours. Now the Aptera would go about probably 50 miles on 5 kilowatt hours. I think the Model S actually doesn't go 20 miles, probably 15 miles or something. So he's a little bit generous there. But he's getting this 5 kilowatt hour, I think, from the same calculations that Fully Charged did back then. That kind of, when I found out that fact, I had not heard that before, and I was very interested in that, and I wanted to kind of run the numbers for myself. So I made this video, how much electricity does refining gasoline actually use? I looked up information from various primary sources and figured out the electricity that they use. And my calculation was somewhat different from theirs. My calculation was that you probably would use about 2.35 kilowatt hours of electricity per gallon. So about half of what they estimated. And I think the difference is that they were taking the electricity that they were using and turning it, saying that they're taking the energy and saying it was directly proportional to electricity. But you have some losses in energy by turning it into electricity. So I accounted for that, and it gives me half of their number, which I think this is the more honest number, is 2.35. If you're interested in the way I came with those calculations, you can check out my video. I will link both this video and the Fully Charged video in the description below. And this is a paper from the global home of chemical engineers. So chemical engineers are the engineers that run petroleum refineries and petroleum. So these guys, these are petroleum guys. You know, this is their profession. And they say outside the oil and gas industry and their utility providers, it is not well known that the production of oil and gas requires large amounts of electricity. After the natural lifting energy and pressure of an oil field is exhausted, which is nearly right away for unconventional horizontal wells, artificial lift pumping must be put in place to continue producing oil. Most of the pumps placed in oil wells are electrically driven, with the total electricity used directly related to the depth of the well and the volume of fluid to be moved. Even after the fluid and gases are brought to the surface, additional electricity is required. This includes purifying, processing, and separating the pipeline transport for natural gas and natural gas liquids and crude oil. In the case of oil fields, injecting CO2 for enhanced oil recovery. The CO2 must first be compressed by electric-driven compressors, and once produced in the field, must be recompressed for recycling. So drilling for oil, the drills that drill oil wells, those are electric. That takes electricity. Taking the gas and oil out of the well, that requires pumps. Those are electricity. And then transporting it and separating it and purifying it, that requires electricity. Injecting CO2 to get more oil for enhanced oil recovery, that requires electricity to pump it. So, and then after all that's done, then you have to pump it into the tankers, and then you have to transport it. All that doesn't take electricity, but it takes energy. That takes fuel. And if you just stopped a portion of that, the portion which is about 20 to 30%, if you stop the portion of petroleum production that goes to gasoline cars, you would more than have enough electricity to run the electric cars, which is it's fascinating. It's fascinating information. So can we get rid of fossil fuels? Of course we can't. We need fossil fuels. We need gas drilling. There's so many things that we are dependent on them. We need it for, the plastics, for long haul flights, for heating, those kinds of things. But let's keep fossil fuels and petroleum for the things that they're good at. They are not good at turning it into mechanical energy. Electricity is just way better at that. And that's why they use electric pumps and electric drills to drill for oil, because electricity is just better at turning electrical energy into mechanical energy.
I like them. Maybe I'll buy one. But I won't pretend it'll make me some kind of environmental hero.
There'll be lots more electric cars in the future, and there should be, because that'll reduce demand for oil, which is a good thing.
Yeah, so now they're basically saying it. It will reduce demand for oil, and that's a good thing. And that's basically the bottom line.
But when you do the math, the arithmetic on the scales of demand to operate a society with billions of people, with 5 or 6 billion people who live in poverty we can't imagine, when you want to give them a little bit of what we have, the energy demands are off the charts big. We're going to need everything.
Everything includes fossil fuels.
Okay, so yes, true. We're going to need more. We're going to need more energy, and the basically the thing is let's reduce the amount of fossil fuels we use and use it for the things they're good at. Let's not use fossil fuels for the things they're bad at. And we can get to a carbon neutral electrical grid. That's definitely possible. Is it possible without nuclear fuel? I don't think so. I think you're going to have to use nuclear energy. So nuclear energy, if you could get rid of the coal and natural gas power plants and move to nuclear, because nuclear is very good at generating electricity, and solar and wind and tidal power. And that would probably, you could run an electric grid totally on that, and we could make a basically carbon neutral electric grid. That's definitely possible. But is anyone suggesting that we don't need petroleum? No, like the world does not function without petroleum. That doesn't happen. There are things that petroleum currently is like a raw material for that we cannot replace. That may be coming, but that's not coming anytime soon, at least not in our lifetimes. Okay, well, I hope that this gave you guys some information that you may have not heard of before and gave you something to think about, and gave you kind of the other side of the story and some context for what this video was saying. All right, if you made it this far in the video, thank you for watching. Thanks to all of our viewers, and thanks to our supporting members, and have a great day, everyone.